In this lesson, we'll take both the PyData archives on PyServ1 and PyServ2 to create a Pi collective, thereby implementing our first instance of high availability in the Pi system. This enhances the standalone PyData archive architecture by better providing uninterrupted access to Pi system data. Remember that loss of data access can come in a variety of forms, like planned maintenance, unplanned failures, etc. Another benefit of a Pi collective again include scalability, allowing you to place identical PyData archives in strategic locations on the network. We'll start with Pi Collective Manager, a user interface tool that is used for both creating a Pi collective and maintaining existing ones. Existing Pi collectives are displayed on the left-hand pane with their names. When it comes to naming a Pi collective, you can give it a special name, or it's also common to give it the same name as the primary PyData archive. When you click on a Pi collective, you'll see all of its members with a health icon, either green, yellow, or red. If it's not the healthy green color, yellow indicates that the member is available, but there are some errors, while red means the server is unavailable altogether. Before being able to create a Pi collective, let's go over some security considerations. The user who will be forming a Pi collective requires special permissions on each of the PyData archives. Here I have the high availability guide on PyLive library that discusses these permissions. First, make sure that the Windows user has administrative level access on all machines. Second, make sure the user can not only find and connect to each PyData archive, but also has read and write permissions on the Pi replication, as well as the Pi backup tables of the primary PyData archive. These tables can be found in the database security section in PySMT. Again, that's administrative access on all machines, as well as read and write permissions on Pi replication and Pi backup tables on the primary member only. Now, this takes care of the user's security to both PyData archives. In terms of the permissions that the PyData archives need with each other, this is all taken care of behind the scenes. As the Pi Collective Manager steps you through the creation process, Windows certificates are generated and shared with all secondary members. PyData archives can then use these certificates when they need to authenticate and communicate with each other. This eliminates any manual setup of Pi security between Pi Collective members. All right, let's head on over to PyServ1 to begin. Here on PyServ1, let's review those required permissions and see if any have already been implemented. Firstly, we need to have Windows administrative privileges on this machine. We can verify this by looking at this computer's local users and groups. So let's open up Server Manager. All right, and then Tools, Computer Management. Expand local users and groups, and then within this groups folder, you'll find this administrators group. Let's look inside. So I'm going to right click properties, and you will find our users student 01 here. I'm going to back out. Our next concern is with our access to the PyData archive. So open up PySMT, have it right here. And let's check out if any permissions have already been set up for us. Down here in security, I'm going to go to mappings and trusts. And as was explained in the previous video, Pi mappings are used to link Active Directory users to a collection of Pi system permissions. Here you will see 3 different mappings that have been created just for us. It's right here. If you look through them though, there is not any one specifically for our Student 01 user. But our account is actually set up to use this Pi mapping, the first one, which is configured for a domain group called Pi Administrators. Let's briefly jump onto PyDC, our domain controller, to confirm this. Here on PyDC, if we open up Active Directory users and computers that I have right here, we can head to this users folder, this last one, which contains domain-wide users and groups. And here is that Pi Administrators domain group. I'm going to open and look inside. Right-click Properties. Under this Members tab, here you will see that our user is included in this domain group. Great. Let's go back to PyServe 1. Now, we can be confident that whatever permissions we assign to the Pi Administrators domain group will also apply to our Student 01 user. As you can see here, this Pi mapping links us to the Pi admin's Pi identity. By default, Pi admins has access to every resource. And so if we go over to that database security section, we can confirm that Pi admins over here does have read and write access all throughout. In particular, we have read and write privileges on Pi replication, as well as the Pi backup tables. Right? And this is for PyServe 1, which will become our primary Pi collective member. All right, that wraps up the security checks on PyServe 1. Let's now head to PyServe 2 to verify our permissions there. Here, we will repeat the same checks that we made on PyServe 1. So first, open up Server Manager, then Tools, Computer Management. Let's expand the local users and groups, and then groups. Inside the administrators group, I'm going to right click and select properties. We will see that our user Student 01 is included. So good. Next, let's go to PySMT and check our privileges on this Pi data archive. All right, so let's go to Security, Mappings and Trusts. And notice that on this Pi data archive, we have not supplied any Pi mappings for you. Also, although not the best practice, users could rely on Pi trusts for authentication. So over on this Trusts tab, you will see that there is just this default proxy trust. This Pi trust allows only local connections, and so currently there are no settings in place that will let us authenticate remotely, either via mappings or Pi trusts. To fix this, let's go back to the first tab and create a Pi mapping. So up here, I'm going to select New. I'm going to click and search for our user, Student 01. Check names and then OK. All right, now down here for Pi identity, let's go search for Pi admins. So we're going to go to Pi groups and then Pi admins. All right, then I'm going to press OK. Create. All right. By having this Pi mapping, we can now connect to this Pi data archive from a remote machine, like PyServe 1. Note that this Pi mapping was made only to help aid in the creation of the Pi collective, and as was mentioned in a previous video, as the Pi collective is being formed, certain settings like Pi mappings will be overwritten by those from the primary Pi collective member. Before we leave this machine, we can test our Pi mappings that we've created so far. So I'm going to search for the Pi SDK utility tool right here. And in this connections section, I'm going to add in a new server. Right click at server, then PiServe1. Press OK. I'm going to initiate a connection, clicking on that checkbox, and good. So if you see these fields populate like this, and there were no error dialogues, you have successfully authenticated. And here next to the connected user, you can see your Active Directory username, as well as the Pi identities granted to you. This Pi admin's identity is important because on PiServe1, we need that read and write privilege on the Pi replication and Pi backup tables, and Pi admins will give us that privilege. You will notice this secondary Pi identity, Pi readers. Our student 01 user also matched another Pi mapping and received this custom Pi identity. Like that first Pi mapping on PiServe1, this Pi mapping and Pi identity were created just for this course and remember are not present by default. All right, we are finished with this node, so let's hop back to PiServe1. Over on PiServe1, we can test our Pi mappings. So let's open up Pi SDK utility right over here. And then within this connection section, I'm going to right click and add server. This time it'll be PiServe2. Click the checkbox and good. So we see these fields populate. Again, we see our connected user as well as the identities that we have from PiServe2. Here, PiWorld is one of PiServe2's default identities. This Pi identity, if enabled, is given to all authenticated users and acts like a baseline of permissions. Depending on how strict you want to tie down security in your own production Pi system, for example, you may decide to disable PiWorld. And for this course, PiServe1 has had its PiWorld disabled. So once the Pi collective is being formed, this configuration gets replicated onto PiServe2, and we will not be seeing this Pi identity show up anymore. Seeing Pi admins here though, we know that the Pi mapping we just created on PiServe2 is working for us. Now, we are ready to create the Pi collective. Note, make sure you are on this PiServe1 machine. Pi collectives must be created from the machine that will soon become the primary member. All right, let's search for and launch Pi Collective Manager. So start, and then Pi Collective Manager. All right, so this is Pi Collective Manager. To create a new Pi collective, let's go up to File, and then Create New Collective. First, it asks you to confirm some pre-Pi collective formation steps. And for this exercise, let's assume we've checked both backups and the Pi interfaces. So we can click the boxes there and then select Next. Right. It asks us the server that will be the primary server of the new collective is, and then we have some data coming in from a Pi interface node that's remote. So this is an existing server that contains some data. So I'll click next. Okay, our collective primary is PiServ1, and collective name will be PiServ1, or just the name of the primary Pi collective member. Next. And here we have only one secondary server, namely PiServ2. So I'll select that and click Add. Okay, and then click Next. And here we can specify the number of Pi archives to replicate. In a scenario where there are many Pi archives, it'll take a while because the Pi collective formation will replicate all the archives. So if you wanted to just do some now and then the rest later, this is where you specify that. But we only have one archive, so this is fine. We'll just select the one and only one. Okay. We have no future ones, so let's just click Next. And then we'll take the defaults here. This is just a step that the Pi collective creation goes through by creating a backup. Take the defaults, click Next. Okay, so it looks like we're all set. We have a primary server of PiServ1, and then PiServ2 will be the secondary server. Alright, so during this process, the Pi collective manager will, remember, create a backup of the primary Pi data archive. It'll then shut down PiServ2, replicate the Pi data archive on PiServ1 onto PiServ2, thus creating the Pi collective, and then it'll restart the now secondary Pi collective member. Okay, it's complete. It says that the collective named PiServ1 was successfully created. Oops, click Finish. Now, in this collective manager, we can select the name of the Pi collective, and we see our collective members with their health status. Okay. Now we see an X here, but if we wait a few moments, just since this is the beginning of a Pi collective, it may not be totally ready just yet. Okay, there it goes. All right, looks like now the collective has been formed with both members with a healthy health status. Okay. We can do one simple check with the Pi collective. Over on PiInt1, there are a Pi interface instance and the Pi buffer subsystem currently running. So let's head on over to PiInt1. On PiInt1, we can make use of a tool called Buffering Manager, which is a user interface client to see which Pi data archives are recognized by the Pi buffer subsystem and currently being serviced. So to open up Buffering Manager, let's first click on Pi Interface Configuration Utility. All right, and we'll go over this tool in a later video, but at the top, let's select Buffering. And here is Buffering Manager. At the bottom, you'll see that it recognizes the PiServ1 collective. So I'll click that once. And then below is the level of the Pi collective members, namely PiServ1 and PiServ2. And let's drill down on one of them, so PiServ1. Here, you'll get access to information like the total number of values sent to this specific Pi data archive, as well as values that are currently being queued. Normally, this queued value should be close to 0, as opposed to steadily climbing. If the number of events queued is rising, this indicates a connection issue between this node and the destination PyData archive. But no worry, it looks like our system here is running well. That wraps it up for the formation of the Pi collective. We now have 2 PyData archives that users can retrieve data from, taking advantage of high availability features of the Pi system. We were introduced to both Pi Collective Manager and Pi Buffering Manager, and their features within the Pi Collective architecture.